Alright, I'm not going to do all the examples from class. I'm just going to do a couple of the trickier ones. So first start with example 3. So Fiona is building a skateboard ramp. She wants the ramp to rise 1 meter in a horizontal distance and have a horizontal distance of 2 meters. So there's her vertical distance. And there's her horizontal distance. And we're going to keep this ramp just nice and easy. We'll just make it look like that. Just kind of finish it out. So there's our 1 meter, and there's the 2 meters. So the question asks, what acute angles should she cut the wood round to the nearest 10th degree? So what we're trying to find out here is what are either of these two angles. Alright, so what we're going to do is you gotta take 1 second and we'll label this side over here. We know that the right angle points to the hypotenuse, so there's the hypotenuse. Next, let's pick this angle right here to be our angle of reference. So what we'll do is we'll just know that that's our angle of reference. If that's our angle of reference, then that makes this side right here our adjacent side, and that is our opposite side over here. So when we do trig questions, what we want to think to ourselves is, what do we have, or what do we need? So we have the opposite side and we have the adjacent side. And because we have the opposite and adjacent side, we think in our heads of so, ka, and toa, which one has the opposite and adjacent, and that's the tangent ratio, or the toa. So what we're going to say is that tan of theta equals 1 meter divided by 2 meters, and those two correspond to the opposite and adjacent sides. So what I'm going to do now is I'm going to do 1 divided by 2, which is 0.5, and that's the tan of theta. There we go. So what we have to do is we have to move tan to the other side, and what I talked about in class were examples of operations. So I'm going to kind of do a little side bubble here, and this kind of doesn't connect to what we're doing here, but if we talked about operations, there's all sorts of different operations, but we'll just keep it nice and simple. So operations. So example operations could be things like adding. And if I were to ask you what the opposite or the inverse of adding is, you would say, well, that's going to be subtraction. So they're inverses of each other. And if I said multiplying, and you would say the opposite or the inverse of that would be dividing. So with trig ratios, if I gave you sine, cosine, and tangent, just right near buttons here. Sorry, I'm kind of pressing those buttons. Nope. Let's just see if I can write it. There we go. And the tan. Their inverses are sine to the -1. So there's cosine to -1, and there's tan to the -1. And as a result of these, we can use them in a lot of different ways. So if we're trying to isolate in this example, and we're trying to isolate for theta, we have to move tan to the other side. So what we do is, I'm going to show you the optional step, but what you would do is you would say, okay, well, I've got tan to the -1 bracket tan theta equals, and now you move tan to the, what you do to one side you must do to the other, so that's going to be tan -1 bracket 0.5, and that's to the tan to the power of -1. When you write these, it's a form of it's mathematical form to write the tan first and then the number. So what you're always going to do is you'd write tan to the -1 and the number second, and this is good mathematical form. You include your brackets like I have around the number to help organize things. What would end up happening is, if you want to think about it like that, you're allowed to skip though and proceed straight to this. And if you skip from here directly to there, that is fine. And actually preferred. So next you take your calculator and you punch in tan of the -1, and if you look on your calculator, you're going to have to look above the tan key to find the tan of the -1 function. And then you're usually pressing shift or second F to be able to access that. But what I end up getting is I get the angle to be, after I press this in, 26.56 degrees. So now once you know that first angle, you know that one angle right here is 27.56 degrees. You know that angle is 90. Can you find that angle by figuring out what the third angle that adds to 180 is? Of course you could. Could you use trigonometry and solve it or find it using sine, cos, and tan? Yes, you could, but it's just going to take more work. Alright, so the other thing you can do with the sine, cosine, and tangent ratios is if you were given an angle and a side, you can find an unknown side. So what we're going to do is we're going to think. So if this is the angle of reference, there's theta right there. Now let's just take a second and do some labeling. So that means that over here we've got the hypotenuse. That means that 9.2 would be our adjacent side. And over here, x would be represented as is the length of the opposite side, not represented. So what you got to think in your head is, which one of the sine ratios, when your angle of reference is where it's located, uses the opposite and adjacent. And again, that's the tan ratio. So what you'd write now is you'd write the tan of theta equals, I'll write it a little bit better this time, opposite over adjacent, which equals the tan of 28 degrees, so that's our angle of reference, equals opposite, which is x, over adjacent, which is 9.2 centimeters. So we have to solve for x. Now don't forget that 10 is also over 1, or tan of 28 degrees is over 1. And this is that moment where we can review that skill I showed you from the start of the unit, and we can cross multiply this proportion. And so what's x times 1? And I hope that you're thinking x. And what you're going to do, wow, my pen's really not working. There we go. And the next thing you're going to do is you're going to say that equals the tan of 28 degrees. I'll just use dot to represent times 9.2 centimeters, and that's a decimal right there. I don't know if you can really see it. I'll just try to dot the screen 1,000 times and make it look like a decimal. There we go. So now I punch that into my calculator, literally in that order. And what I end up getting as I press those buttons and kind of press the equal sign eventually is I get 4.891 centimeters, and in my final therefore, because it's asking for 1/10 of a centimeter, I could say therefore this x equals, and I rounded that, so I should probably do that, and I rounded this, is equal to 4.9 centimeters. Beautiful.